this time of year.
Good time to go out there.
It's a good time to go there?
Yeah.
It's light, at least. 13 hours of light today.
Pretty good.
Yeah, it's really good. It's more light than anybody south of us right now. Okay, so lesson 8.5. Here's some more things from 8.5 that I think we need to be aware of before we finish that work. Griffin, did you finish that one, or were you looking at a different page?
85?
Or 485 was the homework page. That's where it started.
I did not get 485.
Okay, lesson 8.5. So this is powers of products and quotients. And we had some notes already. So a lot of what these lessons are trying to do is just build upon the previous, build upon the previous rules and start basically incorporating them, pulling them together, making them more and more complex. And like I said earlier, it can be challenging. All of a sudden, you get a lot of things to juggle. I strongly suggest you write each of the rules. You don't need the names, but you could write the algebraic rules in front of you. And just keep them on one page or one place in your notebook where you can refer to them when we're doing this kind of work. And that can make things a little bit more reasonable. So the power of a product is this one. And say, they use N and A and B. So they say, so this is the power of a product. And the idea is that there's a product on the inside, which is A times B. And then this applies to the entire product. So that means if everything's multiplication, it doesn't matter what order we multiply it in. So if this is like AB to the 5th power, that'd be AB times AB times AB 5 times, which would be the same as A times to the 5th power and B to the 5th power. So we can just say that this is A to something, B to that same value. So an example might be like 3 times 5 to the 3rd power. Well, that's 3 times 5 times 3 times 5. And then you can see you have 1, 2, 3 of the 3's. And you have 1, 2, 3 of the 5's. So that's the first one that they gave us. I think if you wrote things down, you already had it written down. We did example number 2, I want to say. So, is that right?
Yeah, we did example.
Yeah, we did number 2, that negative 5x squared y cubed z, all in parentheses, taken to the 3rd power. Okay, so then the next power or the next property that they give us is the power of a quotient. This one we have not written down in the notes yet. And that works like this. If you have something written as a fraction, which is another way of doing division, and that entire fraction is taken to some power, then the numerator and the denominator go to that same power. Now, b can't be equal to 0 here. I'll make a note of that. B cannot be equal to 0. But otherwise, pretty much everything holds true. So an example of this would be like if you took 1/2 and you multiplied it to the 4th power. Well, that's going to be just like this. It's going to be 1 times 1 4 times. 4 times 4 4 times, because that's how we multiply fractions. I'm sorry, 2 times 2, not 4. 2 times 2 4 times. So if you rewrote this as exponents, that'd be 1 to the 4th over 2 to the 4th. And that's what we're doing here. This exponent is applied to both the numerator and the denominator. So that's just going to be 1 over 16. So in the 3rd example, they say use the fraction 3/4 taken to the 5th power. And they say to write it as a simple fraction. So the idea with this is that 5 is going to apply to both the 3 and the 4. Just a note, you guys, if you see a fraction that's like this, where you write your fraction fractions like that, in this case here, the 5 is only gonna apply to that 3. So this is 3 to the 5th divided by 5. That is not the same as this. Or, why I read a 5, I don't know. If I did 3/4, 3 to the 5th over 4 would not be the same as that. So, using the property, how could you rewrite the fraction? 3 to the 5th over 4 to the 5th. So it's 3 to the 5th power. I hope it's not 15. Don't do that to me, Dan. 3 times 3 times 3 times 3 times 3, which is going to be, well, 3 times 3 is 9, right? And then you do it again, that's 81. So 81 times 3. What did you say it is?
It's 243.
243. Bingo. So 4 times 4 is 6. Oh, that one's going to be harder. Because you have 16 times 16 times 6 times 4 again. How much is that, Trenton?
It's 1,024.
1,024. Do you think you can simplify that?
No.
Why not?
Ends in an odd number on the top.
You gotta talk real loud through a mask, sorry.
Ends ends with the odd number on the top and an even number on the bottom. Makes
An
it hard.
odd number and an even on the bottom. Ooh, now you're challenging me to think of something that could have an odd number on the top and an even number on the bottom.
Probably could.
So we need a better rule than that. Because there you can simplify into 1/10, right?
Yeah.
It's right, you can't simplify it, but why not?
You don't have a common denominator.
What are the factors of 3?
3, 6.
Those are multiples. Factors? 3 and 1. What are the factors of 4? Just 2, yeah. So all this is a bunch of 2's being multiplied together. And this is a bunch of 3's being multiplied together, so there's no way to simplify that. So just know that, and don't be looking to simplify things. When the factors, the numbers that we're using to come up with this, are not able to be simplified. Okay. So, this next one here, this is gonna be, you have to take a look on page 483. I'll get you a couple of pieces of paper to work with.
Oh, yeah.
So you gotta make 2 different boxes. First one's gonna be long and skinny. And the second one's gonna be short and squatty. So, page 483, Leo, if you're watching, go through that entire activity, work the whole thing through, and then do your best to try to understand example number 4. We can talk about it when you get back to. I'm not going to have you watch the video while we're doing. Well, maybe I will. So I have a couple pieces of paper. So we got to begin with 1 sheet of paper. So we got to do with it vertically. You got to fold it into fourths. So these are 8.5 by 11. And I think what we're doing is we're just looking like at a, what do they call it, a rectangular prism. We're looking at a box shape that's long and narrow. But the box, the shape of this thing is, it's going to have a surface area which is equal to the whole sheet of paper. So that's important to kind of realize. Mrs. Dagan and I were talking boxes yesterday. Went to the grocery store. That tells you a story. So we go to the grocery store yesterday. I like getting boxes because I have to walk, like 50 yards back to the house after I park. So it's easier having just a whole box of food than a whole bunch of bags, And got a really good box at Hauser's. Kyle's mom gave me a really nice box. It was a really great box. He brought it home. And Joe started talking about the box, about, some boxes are better than other boxes. In this box, gosh, I should go get it. It's out in the truck. It's a really cool box. But the whole thing is really, really sturdy. Does not come apart. But there's no glue in it. None of it's glued together. So all of the folds come together to hold the box as a box when things are folded. This is too good of a story to not have the box. So here's what I'm going to do. You guys are in charge. I want you to work through this activity, step 1, and then take a look at step 2. You're going to need some tape.
Yeah, where's
Tape at?
Yeah, hold up on tearing and stuff though, 'cause I think when you're done with this, you're done, right?
Yeah.
And then you're going to take this piece of paper, your second one, and you got to do some cutting and taping. And then for step 4, you got to do some volume and what does S stand for?
S?
Yeah, S. S is a side length, I think. So you have some calculations you need to do when you get through steps 3 and steps 4. And by the time you're done with that, I'll be back with this box because, sorry, this box is too. I have a big long story about this box. Maybe it'll make sense to some of you. So you need tape, right?
Yes.
All right. So here's your job. Somebody lost the end of the tape. Who's good at this? I knew you'd say you are. Think you can find it?
Probably not.
Yeah, usually I end up just throwing them away. With that kind of thing, that leaves.
It's upside down. Oh, never mind.
But you know what, at the same time, if you don't want to use Scotch tape, there's blue tape. If you need a scissors,
Tape these two like this. It's on the second page.
there's a bunch of scissors.
You need a bunch of-
I will be probably 2 minutes.
Yeah, I don't need to tape it. This is pretty quick. Raven, why don't you post on Instagram like Joe?
Yeah, everyone loves when I post for attention.
You post everything, and it's amazing.
I like to post for attention.
Taylor, I mean, Raven, why don't you?
I'll do better.
Good.
I thought that. Are you still going to do it? No, it's still not bad. You can see it.
One last.
It is an awesome box. It is like the most incredible box. The biggest problem is, when I be able to put it back together.
What happens when it gets wet?
What's that?
What are you gonna do when it gets wet?
I'm probably not gonna worry about it. That's it. Okay. How did this one work? Oh, this is a pretty simple box, I think. There's always a trick to doing it. Once you get it, you can do like 1,000 of them in a day. I've had jobs before where my job was to put a box together and put it in front of a person, and they'd shove packages of cheese into it. Not a job that I would want to do for very long. But there's a technique to it. And once you got that technique down, you can just do it in your sleep. Which pretty much made it so I didn't want to have that for the job for the rest of my life. So I went back to college. But there's truly an art to some of this kind of stuff. And that art is, oh, here we go. So somewhere or another, you gotta have this in place, and then this goes up. Then it comes down over the top. And then those things get bent and they come out. Then you have a box that when it's full of stuff, it doesn't come apart. It's got a little top on it. Yeah, crazy. It's just a box. But what's crazy about it is that once it's put together like this, I had probably, I don't know, probably 40 pounds of groceries in here, 30 pounds anyhow. And it was like bomb-proof, rock solid. The box has a ruler on it. Yeah, I know. See, isn't it a cool box?
In case you wanna measure your groceries, yeah?
Yeah, well, it's not for groceries though. The box is for, what did you say? IPR Fresh. Yeah, that's a company, I guess. IPR Fresh. The box is made by a company in West Rock, Atlanta, Georgia, by the company West Rock in Atlanta, Georgia. Agra Packaging.
You should order more.
Oh, looks like it was made maybe in February,
What year, 24th?
no, 24, 21, February 24th, 21. Or maybe it was designed then. I don't know.
I doubt it. I don't know why, I don't think they put the design date on it.
But it's but now the food is IPR Fresh. And IPR, I don't know who they are, but they're out of Nogales. Nogales, Arizona, that's one of the border towns. You know where Nogales is.
What?
You know where Nogales is?
Nogales?
Yeah,
My dad used to work there.
see, there you go. Oh, he worked border there, didn't he?
Yeah.
Does he work border here?
Mm-hmm.
Oh, okay. Yeah, he's like the only nice guy up there. That's right, I remember coming through and running into your dad. So he worked Nogales, oh golly,
Mm-hmm.
that's hardcore. It's like really hardcore, they got a freaking wall about 25 feet tall. You get tunnels under the wall and everything, it's crazy there. So anyway, these are yellow peppers. This is a yellow pepper box. So other than the fact that it's a nice stout box,
They used to have yellow peppers in.
you fill it with peppers, so there's the ruler, right? Well, these are gonna be all number ones, these gotta be this big of a pepper, these are gonna be number twos, well, they can be this small of a pepper. Yeah, makes sense? So, the people, the agricultural workers that are out in the field picking peppers, they've got boxes like this, probably sitting on trailers, and they come up with the peppers that they pick, and they box them.
You should go there and steal some of the boxes. I
Well,
doubt they'd notice.
My guess is that there's probably a trailer of boxes, but they're just flat cardboard like what I walked in here with. And there's probably somebody that they probably shift in and out of doing this so they don't burn out, because imagine folding boxes all day. I can't, because I've done it, it sucks. But you probably, spend 45 minutes or half an hour doing that, and then you switch and do something else. So what they do is they got a stack of cardboard on the trailer like that. They grab the boxes, they fold off, they set the box down. Grab another piece of cardboard, fold it up, set the box down. And you got other people that are picking the peppers and bringing them over and putting them in. Maybe they're set up that people are picking the peppers, and it's coming off of a conveyor that's going through the field really, really slowly. And everybody's walking along picking peppers. And then you get somebody who's making boxes. But the box itself, you may think to yourself, well, yeah, big deal, it's just a box, right? I don't even have it put together properly. See, there's a little hole there for this to snap into. And this is going to snap into there. And I think once you put it together once, it doesn't snap together as nicely as the very first time. But you may say, well, this is just a box. But look at all the openings. And look at the intricacy of the box. Somebody had to design this box.
Must have taken a really long time.
Yeah, I probably did. Somebody had to design this. They didn't just say, oh, here's a hunk of cardboard, cut it up, and there's a box, that's good enough. What do you think had to go into this box design? What were all of the considerations they had to take into account?
How strong it was.
Strength?
I bet it was AI designed.
What do you see for strength? What makes this a strong box?
Things on the inside folding over.
Things on the inside folding over? Can they stack these? I wonder if you could stand on them. Probably not.
You
But
should try.
it's pretty close. I don't know.
That's pretty impressive.
It's pretty good, huh? Yeah, so if you set things on it properly, it's a pretty dang strong box, man, 185 pounds, and I just stood on it. And I was only on 3 of the 4 corners. So you can probably stack up your peppers and not risk your peppers getting smashed, right?
Hopefully.
I mean, if I'm 185 pounds, what does this box say for capacity? Does it say? It doesn't say how many pounds you can put in it. Some boxes do. But clearly, if this is full of peppers, it doesn't weigh 185 pounds.
The boot really strong.
What do you think it weighs if it's filled with peppers? £11 pounds.
Probably less.
So it says, so maybe, it says net weight is 11, so it's probably within 10% of that. I didn't see that right away. So you could stack like 12 of these. And the one on the bottom is gonna be strong enough that your peppers are safe. It's got a ruler. It's got ventilation holes. So how did the peppers get here from Nogales? And they got the Hausers, right? How does Hausers get all their food up here? On the barge, and in the barge they're inside of a,
Great.
in those containers. Okay, so you're paying to send all your food and everything up here. Do you think that you want to have a container that's packed crappy, or you want it packed nice and tight?
Tight.
Nice and tight. So do you think this box is set up to be the size that when it goes inside of a semi, by the way, it had to leave Nogales in a semi, and then get put into a container? Or maybe it was put into a container right out of Nogales and then they drove it all the way to Seattle? Or maybe it got put into a train, a boxcar of a train that was refrigerated and then taken to Seattle. But then again, maybe it was put on the jet and flown to Juneau and then just barged here. You know, a lot of the produce gets flown up here in the winter months in particular, because they lose so much in the quality of it on the barge, and they're not selling as much food. So what they do sell, what does arrive, because we don't have all the tourists and everything here, they're selling less food. What does arrive has to arrive in better condition, because they can't afford to lose as much due to damage from temperatures. So they fly a lot of stuff up here. So maybe this has gotta fit into a 737's cargo hold, and it's gotta fit into maybe a container, and into a semi-trailer. And if you go and you fill up the semi-trailer, and you line up all your boxes, and you end up with 4 inches at the end, you're wasting space. And the boxes were gonna move. So I'll guarantee you that this box is made so that when you set it inside of a semi, it fits perfect. That last box probably goes on and fits in just like a glove. I've loaded a lot of semis, I know how that works. And then in the container, it's gotta do the same thing. And when they put it on the jets, it's gotta do the same thing. There's a lot of thought that goes into just making a box.
Maybe I should be a box designer.
There you go. So Joan and I were talking, and she says, I wonder what kind of engineer does that? And I said, I think that's industrial engineers. But engineers do this. They don't just say, oh, yeah, you can scratch with a pencil. Go design a box. People that do this are paid really, really well. And they get a lot of specialized training of problem solving. Because every box that they have to make has different qualities that they have to be able to meet. So I just had to share the box with you, because I think the box is kind of cool. So your big long rectangular prism and your squatty one. Do you have your measurements for volume? Length times width times height. Take the footprint and do the height. Let's just do this. Let's set them up there on the side somewhere, next to that GIF box up there, if you would. And then we'll just come back tomorrow and we'll finish this up, and don't worry about your homework unless you have not done numbers 1 through 9. If you need to do numbers 1 through 9 in this lesson, complete those. Otherwise, we'll pick up and finish this tomorrow. Maybe we'll have a different box. Yeah, it's a pretty strong box. I didn't stand on it last night.
You can show John.
What's that?
You can show John that you can stand on it.
Let's do it this way. All right. Make seats out of it. Could save lots of money around here. Have a good day. Goodbye.
Hasta mañana.
Later, Mr. Deegan.
Later. See ya.